This lesson is an introduction to combinatorics. Combinatorics is how we count and arrange things. So our objective is to be able to calculate combinations and permutations, which are part of combinatorics. Now let's talk about the fundamental counting principle. If there are m ways to make one selection and n ways to make a second selection, then there are m times n ways to make a selection from each. So as an example, if I've got 10 jerseys and 3 baseball hats, and I select one of them, okay, I select a jersey, I select a hat, then there are 30 ways, 10 times 3 ways to select a jersey and a hat. So I would have different combinations of a jersey and a hat, 30 different ways. Now, background information about that we're going to use in calculations later is what is called a factorial. A factorial is where you take, if you have n factorial, it's n times 1 less than n times 2 less than n times 3 less than n, and you just keep multiplying all the numbers until you get down to all the way down to 1. Now these are the counting numbers, which are called the natural numbers. So another way to state that is it's the product of n, the number we're taking the factorial of, and the natural numbers less than it. Less than n. Okay, so as an example, if we want to take 5 factorial, that exclamation point means factorial. So what 5 factorial would be is 5 times every natural number less than it is 4, 3, 2, and 1. And so if I multiply 5 times 4 times 3 times 2 times 1, if I multiply those together, I get 120. That's what 5 factorial would give you. Now just a note, if you ever come across 0 factorial, what that means is we've eliminated all the factors. When we eliminate factors, we're still left with 1. So we're going to make this statement that 0 factorial is equal to 1 if you come across that. Now let's talk about what combinatorics is. Combinatorics is the mathematics of counting and arranging. All right, now usually there's a lot to combinatorics, but what we will usually talk about is what's called permutations and combinations. These are the two that we're really focused on in this lesson to be able to work with and calculate. Now, permutations is the arrangement of objects in a specific order. Order matters for this one. So the arrangement of objects in a specific order. So order makes a difference here. That's the big difference between permutations and combinations. Order matters here, it does not matter here. All right, so for this one, the notation we use is a little subscript n with a p and then a subscript r. So these are subscripts down below the line to show us that we've got a permutation. This is read as n PR on this, and what it means is we want to select our objects from n objects and order them. So let's say that we've got a classroom of students. So if I'm going to select out of the, say, 22 students I've got in class, I'm going to select 5 students out of it and put them in order. Notice that lining them up in different orders would be a different grouping for that. That would be a permutation. All right, so the formula for this, in order to figure out how many different ways to do that, is the formula for NPR is a fraction. Okay, that in the numerator we have a factorial. You just take the number of objects in the group, n factorial, and in the bottom you take the number in the group and subtract the number you're choosing. So it would be n minus r, and then take the factorial of that. And then we'll have some reducing down to get to the answer of that. So as an example, if I had 22 students and select 5, then the way we do that, there'd be 22p5, we'd have a 22 factorial, and in the bottom we'd have 22 minus 5 would be 17 factorial in the bottom, and we calculate that. All right, well, we'll get to some more examples in just a minute. Let's talk about combinations and the specifics around that. Combinations are where you choose objects with no specific order. So that same example as I used, if I was lining those 5 students up in front, if I just said, hey, I'm choosing you 5 students, I want you to go help help set up for the play, and those students would just go down and help out. There's no specific order for those students. That would be a combination. So the notation we use this would be that same subscript n. We'd use a C for combination, and then with the R. And for this notation, this means choose R objects from N objects. Let's redo that last objects there. So you don't put them in order though, that's the difference. You put them in order for permutation, you don't put them in order from here, you just take the group. So the formula for this would be NCR would equal the n factorial on the top, and on the bottom we're going to now put, instead of just having the n minus r factorial, which we'll have an r factorial first, and then the n minus r factorial. This means it will be a smaller amount because grouping or order doesn't matter for this. So for our 22 students choosing 5, we'd have 22 factorial over, this would be a 5 factorial, then 22 minus 5 would give us 17 factorial for that. All right, so the key question is, does order matter? You have to ask that question in the situation. If the order matters, you pick permutation. If order does not matter, you pick combination for it. All right, let's try this now. Let's do a few examples here. This first one, let me just raise it up a little bit here for us. Okay, so Coach Ella wants to list a softball lineup for 12 players on the team. So that order does matter. There are positions on the team. So when we do this, what we want to do is use a permutation for it. So it's going to be 12 permutation, and we're going to select 9. We'll do it without as a designated hitter, just 9 position players on the field. And so to calculate that, what you would get is you would get 12 factorial in the top. On the bottom, you do 12 minus 9 factorial. So this is going to be 12 factorial over 3 factorial. Now what that means for the math to go ahead and simplify this, it's going to be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times, and then we'll have 3 factorial because that's 3 times 2 times 1. And so you can always, when you're reducing, go ahead and reduce off the 3 times 2 times 1 as just a 3 factorial. And then we have to multiply these together. And when we do that, we get a total of 79,833,600. So it makes a big difference for putting them in order. That's a lot of different possibilities of lining those students up, or those athletes up onto the team. All right, now Mark wants to select 4 out of his 10 friends to come to to his backyard and hang out. Okay, so to do that, well, because it's just saying choosing 4, it doesn't say put them in an order or anything like that. This is going to be a combination. So we're going to have 10 choose 4 out of that. And that combination, what we'll do is 10 factorial in the top. In the bottom, we'll put the 4 factorial. And then the same as this one, we're going to take 10 minus 4 factorial. Okay, outside. So this one, I'm going to do the 10, this is going to be 6 factorial. So what I'm going to have is 10 times 9 times 8 times 7 times 6 factorial. Down here, I'm going to have the 4 factorial will be 4 times 3 times 2 times 1 times 6 factorial. I'll just pick the bigger one to go ahead and put as the one that I cancel out for 6 times 5 times 4 times 3 times 2 times 1. You can also do more reducing here if you want to. 4 times 2 is an 8, 3 goes into the 9, but then you can also do it on your calculator, and when you get that, you get 210 for that one. Okay, so there's 210 different ways you can select those 4 friends. Okay, now we've got a problem here where we have a bag of chips that is a blue chip, a red chip, a purple chip, a green chip, and a yellow chip. That's 5 chips. We're going to choose 2 out. Now it doesn't say put them in any order, so we're going to have 5 chips. We're going to choose 2. So that's going to be 5 factorial. That's going to be over, down here we're going to have our 2 factorial, and then we're going to have 5 minus 2 will give me a 3 factorial. So I'm going to do 5 times 4 times 3 factorial, all over 2 times 1, which is just 2, 3 factorial. 3 factorials cancel. 20 over 2 gives me 10 ways that I can just pick 2 chips out. Now, if I want to keep them in order, like how I pick the first one out and then I pick the second one out, and like for instance, a purple and a green is different than a green and a purple. That's keeping them in order. So that would be a permutation. So I'm going to take 5 and I'm going to have a permutation with 2 chips being pulled out. That's going to be 5 factorial. And here I'm going to have it just over the 3 factorial, 5 minus 2 for the 3 factorial. So 5 times 4 times 3 factorial, all over 3 factorial. The 3 factorials cancel, and you end up with 20. So our objective was to be able to figure out permutations and combinations. And the key is being able to know, does order matter or not? So if you have order matters, then you do a permutation, and you use the formula for that. If order does not matter, then you use a combination.